Right, in our quest to learn this thing, so far we've got it out of the box, got a brief familiarity with the machine. We've started with a CAD program in order to draw the model that we want to actually make, and somehow we've got to get that model into this machine to get this tool head to work. Now, it does seem like an awful lot to do, and if you want to learn absolutely everything about everything before you even start, it is an awful lot to do. But then, of course, it's like any burger, any elephant burger. When something's great and big and huge, the way you do it is one bite at a time. You don't need to learn everything before you turn the machine on. You just need to learn enough to actually do what you want to do, because learning is an experience. It's a journey like this is a journey. You're going to get in depth as you do, as you progress and find things that you don't know you want to do. You'll learn them at that time. All we're really doing is learning how to get going, and to be honest, that's not that difficult. I mean, we've been at it a couple of days, but then remember, I have to make these tutorial videos as well, so it's much longer for me than it might actually seem. Actually, it's only been a few hours, but even so, we've got to learn how to get that model into this machine. And this machine has a computer in it, an industrial computer called a controller. The controller understands its own language, and we have to convert the language of the model into the language of the controller, so the controller can send messages to the motor. The motor needs to be told how fast to spin, where to go, and what path to follow. If we can tell it that, then this machine will do anything we want it to do. That language is G-code. Actually, there's quite a few, but G-code is the predominant one. It's the winner. It's the one that everybody uses, and then it stands for geometric code. It is in fact just a list of numbers. There's a list of numbers that gets sent to the controller in the machine, and the controller in the machine understands that as instructions of where to move that motor to, what path to follow, and how fast it needs to be spinning. Of course, if you're familiar with this thing, which is a 3D printer, these ideas won't be new to you, because this is a computer-aided machine. It's the CAM part of CAD-CAM. And that link between the drawing and the machine we're already very familiar with. It's the slicer. The slicer does exactly that. It takes the model, cuts it into slicers, turns it into that numeric code, G-code, which is instructions sent to the computer on here on how to move that tool head and how fast to extrude it, and so on and so on. This is just an example of the CAM part of CAD-CAM that you're probably very used to. Indeed, the same thing could be said for this thing. It's a CO2 laser cutter, another computer-aided machine that needs that conversion between model and machine. It's quite common with 3D printers and laser cutters for the company to send you the CAM software, or if you like, the slicer, and it comes with the profile settings for their particular machine. With CNC, that's actually more unusual. You don't usually get that. And unfortunately, even though there is a standard, G-code has a standard defining it, there are always tiny little differences between controller boards and machines as the manufacturer makes them. And so they release profiles, and quite often you need to add that profile into whatever CAM software you're going to use in a process called post-processing. It takes the standard and makes it specific for the machine, which is a bit inconvenient if you think about it. But these guys, Makera, have actually produced their own CAM software, which is pretty cool. And what that means, of course, is that post-processing won't actually be as necessary, because the MakeraCAM software contains the profiles for the carver and the carver air. I actually was pretty impressed when I found that out. But it does mean that you have a choice. You can either use a CAM software that is from somebody else, and we're going to have a look at FreeCAD CAM software, or we can use the MakeraCAM software in the same way that we'd use a 3D printer slicer, and we're going to have a look at that too. Right, we're back in FreeCAD, and in FreeCAD we've got this selected, which was the gear that we made in video 2390. Notice it says gear and gear is bold. We're in the wrong workbench, so we need to take this gear to the CAM workbench. When we click on the CAM workbench, of course, the tools change. The first tool we need to apply is this one here, green square, little sort of drill bit icon. Click on that because that creates a new job. And it will pull up this screen. Now, we don't have any templates set, but we can take care of that later. All we really want to know is that gear, which is the one we want, is in fact selected as a job, and then we click OK. When we click OK, we'll get some tasks. And there they are. And you'll notice it's drawn a little box around that gear. That box is actually material definition. So it's the blank stock that we're going to cut our gear from. It selects it for us. Now, when we look at the tasks, we can see we're in Layout and Create Box, and it's created a box around the gear that's actually slightly bigger than the gear, but that's going to be my stock. You can change this. Obviously, you can click on there and you've got Create Cylinder, Use Existing Solid, Extend Boundary, and so on and so on. So you can play around with this, but I'm quite happy with it as it is. Now, one of the things I need to do is let it know where to start, and that is to set the origin. So if I click on that corner right there and click Set Origin, then that's going to be where my tool starts. So if you think about the bed that this is going to sit on, it's going to be a box of stock, the size that we've got, or slightly larger, doesn't really matter. That will be the clamp on that corner there, and there'll be assisting clamps here, 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 and here. So the tool head will go right to there to understand that it's got to start there. Okay, for me, there's not a lot else to change there. Let's have a look at output. On output, we're going to use G54, and here's the bit that I was talking about the post processor. It's right there. If we click down on that, then we have a whole load of them that we can actually choose from. We're going to use generic on this one, actually. But here, you need to check your post processor against your actual machine, and that's usually supplied by the manufacturer, and you would put that in the processor section to get the post processing right. Okay, let's have a look at the tools. Now, we're in Tools, of course, we can see there aren't any tools, so we need to add a tool, and that will take you to a tool library. The tool library is here in FreeCAD, and we've got these bits that already came with FreeCAD. Now, of course, I have different tools on that machine, so I'm going to have to set up an FCTB file for the tools that are actually provided. But at the moment here, we're just going to select a 5mm end mill and add that as a tool to the tool selection. And okay, so that pretty much sets up the job. We've got the part, we've defined the size of the stock, we've selected the tools. Now, of course, what we need are some operations. Okay, we're back in the job screen, and here we've got these tools. These define operations. Now, what I want to do is cut those holes out right the way through, because I'm not going to drill them out. They're 14mm, that wouldn't fit in the machine. I'm going to mill them out. In order to mill them out, you use this one here called a helix. We click on the helix tool, and it'll pull up this basic task. So here are the details of the operation. We've got our tool that we've chosen. We've got no coolant. Remember, it's air blown. It starts from the outside. The direction is climb. You get a choice of climb or conventional. Step over percent. The step over percent is how far it moves in relation to the tool bit. So it's 50%, which means it'll move 2.5mm. You can change all of this stuff if you want, and you can click on base geometry, etc., and explore it. I'm okay with what it's got, so I'm just going to click apply, and we get the tool path. This is showing you how the tool will actually move. One thing actually that's interesting is heights. We've got safe height. Now, the height of this material is 3mm, it's identical to the safe height. That's how far the tool head will move up from its job to make sure that there's clearance. If you don't like that safe height, you can change it. You can just type in something like 4mm or 5mm. Then we've got clearance height. The clearance height is how far it will move, and you can see that in the red lines with the thing moving up. And again, you can change that if you like, but I'm okay with the way it's set, so we can click OK. That defines the tool that's going to do this operation. Now, when we've got that, actually we can have a look at it. If we go to here, then we've got CAM Simulator. Click on CAM Simulator and you'll get this next screen. click on the play arrow and it will simulate the toolpath in the material for you, showing you what it's actually going to cut out and how it's going to cut it out. So it cuts out that baseline geometry that we set to create us all of our holes in our material. It's pretty cool, actually. Okay, so we can see that the job that we've defined will actually be doing it. What it's doing now is milling the edges to make sure that they're nice and clean. When it's done that, don't click OK, because if you click OK, it'll save it as a file. Just click Cancel, and it'll go back to the original drawing, and now we can do another operation. Now, I appreciate that was a little bit whistle-stop, because it's all the same thing. You basically make sure that you've got your tools in your tool library, and if you don't, you'll have to import them. Make sure you've got your post-processing file ready, and that's in the correct place, otherwise you'll have to import it, and then start a job. The job defines the stock size that you're going to be using and the model that you're going to be applying the operations to. When you're happy with those, then set up operations, which is the actual milling component of it. Now that's the briefest introduction into how FreeCAD handles this. But of course, Makera have supplied MakeraCAM, which means a lot of those tool profiles and the post-processing profile, which you would otherwise have to add, are going to, well, rather they should be, I haven't looked at it yet, readily available and save a bit of work. And I'm essentially at heart a lazy kind of guy. I want things to be as easy as possible. And seeing as Makera have provided MakeraCAM, what we're going to do now is look at MakeraCAM that goes with the Carvera and the Carvera Air. So let's have a look at that. So to find it, just go to Makera on their main screen, and here it is, MakeraCAM. Download it for Windows or Mac. Right, when you've installed it and double-clicked it to open it, this is the welcome screen that you get. And you can see you can choose between 4-axis and 3-axis. 3-axis is basically where you bolt it to the plate. 4-axis is where you use a little sort of lathe attachment. I want to click on 3-axis and it will start as a new project. And there's the project page. And when we look at this, because it's really trying to do one job, I mean, you know, it's spread because, of course, it has a laser cutter and various tools, but it's a much cleaner interface, and that obviously is helpful. But it follows the same procedures. The first thing we need to do is define the stock, and here, presto, on the left hand here, we've got stock. To edit it, you click the edit and it gives you access to these things. I want to make mine in aluminium, of course, and the length of my stock is given here along with the height, because I'm going to make it in that big block of aluminium that I've got. And so we're fine there. We can just click OK. The next thing to do is to actually import the model that you want. Now, this won't take a huge range. I mean, because of the laser, it'll take JPEGs, I believe, and PNGs, so scalable vector graphics. Has a trace element to it. It'll take STL files. It'll take STP files. So it takes a whole load. Again, just click on it or explore it. Now, there are some really good tutorials that Makera have done. Makera are giving a lot of support to this, and the tutorials are absolutely brilliant. So I don't really intend on going into a huge amount of depth. We're just going to whiz around it. The guidance is like all of this guidance. When you're really interested in something, look into it. This is just to give you a flavor of what it's actually like. When we scroll around that, we can see there's a top plate that we actually made in the video when we did on FreeCAD. And if we swing that up, we can see that it's the wrong way around. Because either I'm going to have to change the origin, which I can do by clicking on a point in the corner to change the origin, or I need to rotate that whole thing. So if we click on that, and we can do adjust object, you can see we've got transform and then we've got rotate. If we click up on rotate, then we can see the planes that we need to actually move it in, and clearly we need to move it so that we can actually get that thing to be in the right orientation. We need to rotate it by 180 degrees along the XZ plane, sorry. So 90, 90. And suddenly it's the right way up. And now when we mill it out, we'll be able to mill out this pocket and this recess and drill out these holes and cut the thing around. Now we've got our stock set, we've got our model in, our models placed. The next thing to do is exactly what we did in FreeCAD actually, and that is to define the paths that we're going to do. So the 3D path, the first thing we really need is a pocket. We need to get this part out. Now this is a step file that I used, and step files allow you to use the planes of the surface that you're going to do this on. So we can click on a plane surface so that we can actually cut a pocket in the plane rather than trying to cut across the whole surface and generate the surface as if it were an STL file. We can actually click on separate elements of it to select those elements. When we want to do the 3D path, then we're going to do 3D pocket, and we're going to put the pocket onto that plane. If we look on the tool lists, then we can see that we've got this set tool here. As it happens, that's fine, so I don't plan on doing anything about that. There are various cutting depths and clearance heights and retraction heights you can play with and change. You've got different path strategies that you can use to cut that out with. You've got the most important thing I consider, which is the boundary. If we cut that to the outside boundary, then it's going to follow the path along the outside. We obviously want to cut the inside out, so click on inside boundary. Again, watch the tutorials and you get a good idea of this. All I'm going to do is quickly do calculate, and it will create the path for me. And that's the tool path that you can see there, and we can click close. The next thing we probably need to do is to cut out that center bit that we were just looking at. So if I just swivel that up, this bit here, we need to cut that out. The way to cut that out really is using the contour. So if we click on 3D contour, we need to generate contours. Oops, let's select the mesh first and then generate the contours. And there's a contour in there. We want to work on that contour so that we cut all the way through. We've got start depth, end depth, offset. Again, things to actually play around with that I'm not going to bother with just right now. I'm just going to go straight down here and again do inside, calculate it, and then close. And we can see that it's going to cut that bit out. That's the paths it takes to cut that bit out. If we then swivel our way back up to the top, we've got these contours that we need to actually do, and then the outside contour that we need to do. And we follow exactly the same procedure. Right, when we've done that, our design is ready to go, and we can now export our path. So click path, click export, and we've got all of these we want to actually select because we want to select the whole thing. There we go, just checking my tools, and then we can export it. So I would have said, as a tutorial video, this one's actually a bit disappointing. I wouldn't have called those tutorials. They're more of a zip through to get a flavour of it, because tutorial videos really need to be a little more in depth. But then this whole series of videos isn't really about that. The whole series is really about getting this up and running and getting a sense of what it is that you need in order to get this up and running. And if you're actually absolutely completely new to this, then yes, you have a task in front of you, but none of it is particularly difficult. There's just a fair bit of it, and it's an elephant burger, and so one bite at a time. If you're coming from the world of 3D printing, to be honest, I think that's a huge help, because these are very, very similar to 3D printers, and that transition from one to the other should be very much easier. Now, at the beginning of this, I said you're going to need to get to grips with CAM, and you are, and that's what we just give a quick introduction to. And that means, to a degree, using a CAD program that is fully featured. Well, that's not strictly true, hey? I mean, MakeraCAM, I think actually is pretty awesome. It's a very clean, very simple interface in which you can take a whole range of files, including STL files. STL files are the output of Tinkercad, but it understands them as surfaces. And so it's manipulating a surface rather than manipulating geometric shapes. And so some of the toolpath commands that you're going to be using are perhaps not as refined as if we're using geometric shapes. And so you can come straight from Tinkercad into the CAM and use this machine, but I personally think it's better if you make that step into a fully fledged CAD program. Now, I'm looking at CAM programs, and CAD programs do contain them, But MakeraCAM, I think, is specifically designed for this, and given its wide range of import, actually is pretty impressive. I kind of like that a lot, so I'm going to be focusing on using MakeraCAM when it comes to making this machine actually turn on and do its job. Now, it has been a bit of a journey, been quite a few videos about this, and we've still to turn this machine on. But like I say, I want a true representation of what this takes. I don't really want a 10-minute video where we get out of the box and go, wasn't that easy? I want a true representation of what you need to do if you're going to be using one of these machines, thinking about one of these machines from ground zero. And that's what we've been aiming at. So the next job, of course, we've got our tool path now. Now what we need to do is get it on here and cut it out from something. So I hope you enjoyed the video, I hope you're enjoying the series. Thank you very much for watching, and please do remember to like and subscribe.